Hello, everyone, and welcome to Algebra 2. This is section 7.4, adding and subtracting rational expressions. So my first question is, what is 2x over x plus 6 plus 5 over x plus 6? And if you're thinking, isn't it just 2x plus 5 over x plus 6? You would be right. Because in the simplest form, most people recognize that if you have a common denominator, you can add fractions together. The hard part is getting a common denominator. While you may be used to doing it with numbers, so if you had 1 over 6 plus 3 over 8, you could look at two numbers and come up with their common denominator. You might say to yourself, oh, they both go into 24. So this would be 4 24ths, and then this one would be 9 24ths. You would get 13 24ths. But that's because you can look at 6 and 8 and know what the least common denominator is. If you hadn't known the least common denominator, some students rely on just multiplying the denominators together, which that would mean you would make this 48, 8 over 48, and then this one 18 over 48. And you can do that, but then you'll have to reduce, which is not a terrible thing. You can divide them both by 2. But it is a terrible thing if you do it with these. Your chances of reducing this kind of a problem is really bad. So I'm going to explain this first with these numbers to show you how you can figure it out. 6 is the same as 2 times 3. 8 is the same as 2 times 4. So the 6 and the 8 both already have the 2. It's just that the 6 needs the 4. And the 3 needs another 3. That's how you can get your least common denominator, by factoring the two denominators and then seeing what factors they have in common and then what factors they still need each other to have to make them complete. We're going to use that concept to do this algebraically, which is a lot harder, but you're smart and we can do it. So the first step is always to factor. Now in this case, 9x squared is already factored, simplest form, but this one I can take out a 3x and an x plus 1. So I look at their factors and I think this one has a 9 and this one has a 3. So if this one had another 3 on the top and the bottom, that would give me my 9. So I'm going to underline those because those are done now. This one has an x, but this one has an x squared. So this one needs another x. And now they'll both have an x squared. But now this one doesn't have an x plus 1, and this one does. So I'm going to give this one an x plus 1 on the top and the bottom. And now if you look, the two denominators are identical. Now you do not normally have to write this step, but just so that you can see it, now this one is 9x squared times x plus 1. And just realized I wrote 7 there. And this one is 3x squared over 9x squared times x plus 1. So you wouldn't normally write this step, but I just wanted you to see that they do have a common denominator. I'm going to go ahead and cancel that out, distribute, and I get 3x squared plus 7x plus 7 all over 9x squared times x plus 1. There you go. That is how you add two rational fractions. So as you can see, we have 3 more to practice on. I have nothing new to teach you, so you are welcome to go ahead and try these next 3 on your own. Your first step is always going to be to factor x minus 4, x plus 3. I know you're never going to escape factoring, right? 12 times x minus 4. They both have the x minus 4, but this one needs the 12 on the top and the bottom, and this one needs the x plus 3 on the top and the bottom. And once the two denominators are the same, you know you're ready to go. So my new denominator is going to be 12 times x minus 4 times x plus 3. And then this one, I'm just going to go ahead and write this above here. This is 5x plus 15. So I have 12x plus 5x is 17x plus 15. All right, if you still haven't stopped the video to try one on your own, you might try the next one. So this is going to be 1 over 3x squared. And this one is going to be x over, I can take a 3 out, and I get x squared, 3x squared minus 4. 3x squared minus 4. So they both have the 3, but this one needs the x squared on the top and the bottom. And this one needs the 3x squared minus 4. If you don't write it on the top and the bottom, I will not give you credit. Because to just write it on the bottom isn't algebraically correct. You're multiplying the top and the bottom. That's what keeps the fraction equivalent. So now, on this one, I have 3x squared minus 4, and on this one, I have x cubed. So when I put them together, I have x cubed plus 3x squared minus 4 over 3x squared times 3x squared minus 4. If you wanted to multiply that denominator out, you certainly could, or you can leave it like that. Either way. But you do have to multiply these together. Notice I've been doing that every time, because that's the only way to add your numerators together. Next one. So your first step is always to factor. Actually, I can simplify this one a little bit. You should look for that. So this reduces dividing them both by 4 to 2/3. So I'm going to rewrite that one as 2 over 3x squared. And then actually, I'm looking at this next one, and I see that I can reduce this one. I can cancel that x and that x and make it 1 over x plus 1. Now, ironically, I always like to simplify as much as possible before I start a problem. Ironically, I'm going to need that x. In fact, I'm going to need 2 x's. So the simplification didn't actually help on this side, but I would say for the 2/3 it did, because now I only have to add 3 to both of these. So this one has the 3, the x squared. This one has the 3, the x squared. This one still needs the x plus 1. And that gives me 2x plus 2 here and 3x squared there. So I get 3x squared plus 2x plus 2 all over 3x squared times x plus 1. So now let's just say that you hadn't noticed that you could have done that. Let's say you left it as 8 over 12x squared plus x. You still would have factored this, x plus 1. And if you didn't see that you could cancel the 8 and the 12 or the x's, you would have given this one a 12x, and you would have given this one the x plus 1. That would lead you to, this would be 8x plus 8, and this would be 12x squared. That would give you 12x squared plus 8x plus 8 all over 12x squared times x plus 1. And I would not give you full credit for that. That would be like going back to here and telling me the answer was 26 over 48. It's correct, but it's not simplified. So you would have had to do this next step. So on this one, you would have had to factor out a 4 from the top, giving you 3x squared plus 2x plus 2. And you can think of this 12 as 4 times 3x squared times x plus 1. And then you could have canceled the 4's and you would have gotten that answer. So you are required to simplify all the way, which is why I have a habit of looking for any ways I can simplify in advance. So this next section is literally identical. You just have one extra step, and that is you need to distribute that negative. Now remember that negative 3/4 is the same as -3 over +4, or, though nobody does this, +3 over -4. You can't distribute a negative to the top and the bottom, because if you did that, you would actually be changing it to +3/4, which it's not. It's -3/4. So you can put the negative on top or on the bottom, but you can't put it on both. So on these problems, my first step is twofold. First, I distribute the negative. So this becomes plus 2x plus 1. And then I do everything else the same as last time. I factor, and then I'm going to look for a common denominator. X minus 3 times x minus 1. They both have that x minus 1. So this one needs a 2 on the top and the bottom. And this one needs the x minus 3. So this problem did just get a lot harder. This is the first one where you have to actually FOIL. So I'm going to do a little bit of an extra step here. I'm still just going to write the denominator once, 2 times x minus 1 times x minus 3. But I'm actually going to FOIL that out. So I get x squared. The minus 3x and the plus 2x make minus x minus 6. And then this one is 4x plus 2. So I put an extra step in there to make sure I didn't try and do too much in my head. Some people are better at that than others. You have to decide which person you are, because you need to make sure you get a lot of points on your tests and quizzes, right? Now, on this one, there's actually going to be one more step on this one. Last time, we talked about simplifying because you could see that you can factor out. But on this one, you can't factor out, but you can keep factoring. X minus 4, no, x plus 4 times x minus 1. So that gives me 2 times x minus 1 times x minus 3. My x minus 1's cancel, and my final answer is this. Which, by the way, some people multiply it out. It doesn't really matter to me, whichever way you want to write it. But again, you can't stop here if it's factorable and cancelable. All right, letter B. So remember, my first step is to rewrite the problem, factoring the denominators, and if it's a negative, distributing the negative, 2x plus 1. Then this one is x minus 2 times x minus 1. And this is 2 times x minus 2. So I'm going to give this one the x minus 1 on the top and the bottom. I'm going to give this one just the 2, right? Yep, just the 2. And if you don't want to do the extra middle step, you can just kind of write it above. That's what I usually do. So 10x minus 2, and foiling that out gives me 2x squared. Inners and outers gives me negative x minus 1. You are welcome to do that as long as your work is neat and I can follow it to help you if you find any mistakes. That gives me 2x squared plus 9x minus 3. Now, like last time, I've got to look to see, can I factor that? So here's how you can decide quickly. I actually don't care if you can just factor it. I only care if you can factor it to an x minus 2 or an x minus 1, because that's what would cancel. So I ask myself, could this be a 2? It can't, because that would be 2 and 1, which would make 3. Like, you're not going to make a 3 out of a 2. So it's definitely not that factor. And then could it be a 1? Let's see. If x minus 1 is possibly there. If x minus 1 is there, this would have to be a 2. This would have to be a 3. It'd have to be positive. This would have to be x. And that doesn't add up to 9 in the middle. So it's not factorable, and definitely not the factors that I would actually need to make something important happen. All right, there are 2 more of these. If you still haven't stopped the video, you could consider doing that. So this one, I'm just going to go ahead and just move it. I'm not even going to rewrite it because I don't need to factor the denominators. If the denominators have nothing in common, just like 1 over 4 plus 3 over 5, when they have nothing in common, then you just give this one a 4 and this one a 5. That's exactly what we're going to do. I'm just going to give this one a 2x minus 1 on the top and the bottom. Don't be lazy. And this one needs the x minus 5 on the top and the bottom. And that gives me 3x squared minus 15x minus 8x plus 4 all over x minus 5 times 2x minus 1. And I usually leave it in factored form. I don't usually bother to multiply it out. 3x squared minus 23x plus 4. So I can just look at this and say, I would never be able to factor that to be an x minus 5. It'd either have to be 1 and 4 or 2 and 2, but it's never going to be 5 and something. It could be a 1. So I'm going to go ahead and write that factor down. All I care about is whether or not I can cancel that factor. So if that is a -1, this would have to be a -4. Oh, but 2 times what makes 3? Not happening. So now I know that I'm done. The top might be factorable another way, but I don't care. If I can't cancel it, I don't care if it's in factored form or not. All right, and here's another one just like that. I can put the 5 on the top and make this positive. You can put the 5 on the bottom, but that'll be harder. And then I'm going to give this one the 2x minus 1 on the top and the bottom. And I'm going to give this one the x minus 6 on the top and the bottom. And that gives me 4x squared minus 24x minus 10x plus 5. Now, some people are lazy and they don't want to write the next denominator, but you really need to have accurate work. Then this simplifies to 4x squared minus 34x plus 5, 2x minus 1 times x minus 6. Again, I'm positive that this will never factor to something with a 6. So I check my 2x minus 1, and that would make this a -5. It would make this a 2x, but that doesn't add up to 34 in the middle. So I am content with that answer. So what we're going to do now is usually a little frightening for most students. They see a complex fraction, but we're going to make this great. This is going to be a piece of cake. We're just going to combine this lesson with the previous lesson. So in order to do this problem, I'm going to simplify this first. Now, back to not doing little pieces of problems, it'd be so tempting to just say, I'm just going to work over here on this one. You don't want to do that. You're in Algebra 2. You can do it nicely and neatly the entire way. So I'm going to go like this. And then this, I'm only rewriting it to make it bigger so I have room for my work. So this one needs an x minus 2 on the top and the bottom. And this one needs an x on the top and the bottom. And so this one is going to be 3x minus 6. That pen doesn't want to write that. 3x minus 6. So I get 6 over x minus 2. This 3x plus that x is 4x minus 6 over x times x minus 2. So now, instead of having 3 fractions, I just have a fraction over a fraction. So what can you do? You can flip and multiply. So I'm going to make this 6 over x minus 2 times, so change the division to multiplication, and flip. We did this in an earlier section, and remember that at the same time you flip, if you can factor it all, you're going to want to do that as well. So I'm going to take out a 2 and make this 2x minus 3, because you can't cancel something unless it's in factored form. So my x minus 2's cancel, and my 6 and my 2 reduce to 3 and 1. Now I can multiply straight across the top and straight across the bottom. And that's how you simplify a complex fraction. You do what we learned today, which is adding these together. And then once you just have a fraction over a fraction, it's just a basic division problem, which means you keep, change, flip, or flip and multiply. All right, there are 3 more for you to practice on. So go ahead and try that. I'm going to give this one an x on the top and the bottom, and this one an x on the top and the bottom. And that gives me 2 minus 4x over x all over. I tend to make that line a little longer to show it's the big fraction. And then this is 2 plus 3x over x. So now that I have a fraction over a fraction, I can flip and multiply. I am going to factor that one. I can see I can take out a 2. It may or may not help me. And then I change my division to multiplication, and I flip. So the x's do cancel, but this 2 and this 2, or this 2, none of those 2's cancel. This 2 would be cancelable, but neither of these are. Both of these are stuck next to an addition problem. So you could put that back together as 2 minus 4x, or you can leave it separated. It doesn't really matter to me. Okay. Number 3. So I'm going to give this one an x plus 4 on the top and the bottom, and this one an x on the top and the bottom. Remember, you're not trying to get all 4 to have the same common denominator, or the top and the bottom. Just worry about the bottom. So this becomes 5 over x plus 4 over, this is x, this is 2x, so 3x plus 8 over x times x plus 4. Now that I have a single fraction over a single fraction, I can keep, change, and flip. If any of these were factorable, I would also be factoring during this step. But I didn't see anything factorable, so I'm just going to leave it. My x plus 4's cancel, and my final answer is 5x over 3x plus 8. All right, if you haven't stopped yet, you need to stop. You need to try one of these on your own. All right, next one. This one needs an x minus 3 on the top and the bottom. This one needs an x plus 5 on the top and the bottom. And that is going to give me 3 over x plus 5 over, now this one's a little too much now. I was doing it in my head before, but I'm not opposed to taking the extra step. 2x plus 10 plus x minus 3. I'm always saying it's great to do things in your head, but only if you're consistent in getting them right. And I wasn't confident. So now I have a fraction over a fraction. I can keep, I can change it to multiplication, and I can flip. And now I'll put it together. 3x plus 7. I see that my x plus 5's cancel, but this 3 and this 3 do not cancel. This one's attached to the x, which would be okay if it was just 3x, but it's the plus 7 that's the problem. Think of this as one unit. Addition is always stuck together. Think about this. If you had 3 over 5 plus 3, you know that that makes 3/8. You can't cancel these 3's because it's being added to something. That would make this 1/5. 1/5 and 3/8 are not the same. So you have to be careful that you don't accidentally cancel those 3's. So my final answer on this one is 3x minus 9, or you can leave it in factored form. It's up to you. But sometimes people do all this work so beautifully and they get to this last step and they cancel the 3x's. Don't do that. You can't cancel terms. All right. I am going to show an alternative method. So if this makes sense to you, then I would love for you to learn this. If it doesn't, you can do the next 4 problems exactly the way we did the first 4. So this is kind of up to you. But if it were me, the way I would do this problem is I would look at that denominator, that 2, and I would say, you know what? I can clear the fraction. I can clear the fraction by multiplying the top by 2 and the bottom by 2. So instead of working on each individual little ones, I'm thinking about it as a giant fraction as a whole and multiplying the whole thing by 2 over 2. And I chose that because I knew that then when I did 2 times x over 2, I would just get x. So I cleared my fraction. It didn't help me on the bottom at all, but at least now I cleared my fraction. And then I see if I can factor and cancel. I can, because I can do an entire x minus 2 as long as it's with another x minus 2, and this actually reduces to 1/2. I'm going to do all 3 of these problems this next way, just for people that want to learn it. But if you do not want to learn it, then you can turn off the video, do these problems on your own, and then just after you get the answers, turn it back on to see the answers. So on this one, I would start out the same way as normal. I would rewrite it as 2 over x plus 3 minus, I'm going to change that minus to a plus and put the negative on top and factor the denominators. So far, this is what you would do even if you were doing it the other way. 1 plus 2 over x minus 3. And then, if you're doing it the old way, you could get a common denominator on top, a common denominator on bottom, and once you have a single fraction over a single fraction, keep, change, flip. But if this were me doing this problem, I would multiply the entire top and the entire bottom to clear the fractions. And what would clear the fractions? X plus 3 times x minus 3. Which, by the way, is exactly what you would have chosen as a least common denominator. That is the common denominator you would have gotten. So that's how I'm figuring this out. So I'm going to multiply that by here and by here. When I multiply this by the 2 over x plus 3, think about it. I'm actually going to write it again so you can see. The x plus 3's would cancel. And I would end up with 2 times x minus 3, 2x minus 6. When I do it this time, these actually cancel completely. And I'm just left with minus 4 all over. Now when I do all of this times that, nothing canceled. I'm left with x plus 3, x minus 3, which I know to be x squared minus 9. But then when I do x plus 3, x minus 3 times 2 over x plus 3, the x minus 3's cancel, and I'm left with 2x plus 6. That gives me 2x minus 10 over x squared plus 2x minus 3, which is not factorable, so that's my final answer. Now, number 6 is where I usually lose kids. If this is just not making any sense to you, I assure you that you should not feel bad about that. You should just go back to getting a common denominator on the bottom, getting a common denominator on the top. Once you have a fraction over a fraction, keep, change, flip. That will work every single time. This is a little bit of a shortcut for people that want to learn it. So on this one, I multiply the top and the bottom by the x minus 4 because I can see that's what I'm going to need to clear that fraction, but I have to do it to the top and the bottom. But I'm also going to multiply the top and the bottom by x plus 4 to get rid of that denominator. I am also going to move this negative up to the numerator. So when I do this here, the x minus 4's cancel, and I am left with x squared plus 4x. I distribute that x to what's left. On the bottom, I have to do this twice. I have to multiply it here and here. So if you want, you can write it in extra time to make sure that you're not missing anything, or so that you can physically cancel. Sometimes people just like to do that. So the 3x and the x plus 4, the x plus 4's cancel, and I'm left with the 3x and the x minus 4, which gives me 3x squared minus 12x. And then when I do the x plus 4x minus 4 times this one, the x minus 4's cancel, and I'm left with that negative 2 times the x plus 4, which is negative 2x minus 8. If this is making some sense to you, good for you. It's really a pre-calculus topic, but sometimes I get a couple students that actually like it and want to learn it. Okay, last one. So it's really hard to see the complex fraction, but there's a fraction over a fraction. So the top one is x minus 2 over x plus 5. I'm going to change it to a plus, and then I'm going to make a big line so I can see it better. And I'm going to factor this denominator to x plus 1 times, no, x plus 5 times x minus 1, because I need the 4 to be positive. It would be very easy to do this the other way. You would give this one an x plus 5 on the top and the bottom. You'd give this one an x minus 1 on the top and the bottom. And then you could proceed with keep, change, flip. Okay, so keep that in mind. That's a great option if you understood that better. But if you want to try something a little bit new, then I would multiply the entire top. To clear that fraction, I need an x plus 5. Whatever you do the top, you got to do the bottom. To clear this fraction, I need an x minus 1. And it's my lucky day. That's going to clear that all the way. So that's all I need to multiply by. I'm going to do this one twice, here and here. So I'm going to write it again. X plus 5 times x minus 1. When I multiply x plus 5 times x minus 1 times x minus 2 over x plus 5, the x plus 5's cancel. And I'm just left with x minus 1 and x plus 2, which simplifies to x squared minus 3x plus 2. When I multiply x plus 5 times x minus 1 times negative 1 over x minus 1, these cancel, and I'm just left with the negative 1 in the x plus 5, which simplifies to negative x minus 5. On the bottom, everything cancels. I just have one fraction times this. I only have to multiply this once, and it just completely goes away. 2x minus 3. We'll simplify this numerator, x squared minus 4x minus 3. I do think that that is factorable. It's going to be x. Nope, it's not. I saw the 3 and the 4 and thought I could do 3 and 1 to add up to 4, but that would be minus 3, and minus 1 would give me a negative 4 in the middle, but that would have to be a plus 3, so it's not factorable. And so I'm done. All right, there's just one left. I will tell you the answer in case you want to just skip ahead and try it on your own. If you can get it, great. And I will do this one both ways so that people who need to see one more example of the old way can see it. So I would give this one an x on the top and the bottom, and this one an x plus 1 on the top and the bottom. That gives me 1 minus 3x over x squared. This gives me 5x plus 5. I'm going to move that negative, minus x over x plus 1. I keep the first problem, the numerator. I change it to multiplication, and I flip. When I flip this, I'm also going to simplify that to 4x plus 5. Wow, I don't see anything that simplifies. So, yeah, nothing. So I'm just going to have to multiply it out. So I get know that you have to multiply it out. 1 minus 3x. You can leave it in factored form. I only started to say it because I realized I had multiplied it out. But this is also perfectly acceptable, leaving it in factored form. Okay, so for people that want to see one more time with the other way, 1 over x squared minus 3 over x all over 5 plus, I still would move this negative. So I would multiply the top and the bottom by x squared. That'll clear both of those fractions. And I have to multiply the top and the bottom by x plus 1. That'll clear that fraction. That gives me, when I do it here, the x squareds cancel, and I just have x plus 1. When I do it here, 1x cancels, but I still have the negative 3, the x, and the x plus 1. I still have a lot left. Here, nothing cancels, so I'm left with the 5, the x squared, and the x plus 1. And on this one, the x plus 1s will cancel. So here, nothing canceled. And here, the x plus 1s canceled, and I'm left with negative x cubed. So this gives me negative 3x squared minus 3x. So negative 3x squared minus 2x plus 1 all over. This one is 5x cubed plus 5x. So 4x cubed plus 5x. So now I know why I had that one written in that answer format. I must have done it this way. Because if you're having it in factored form, you can leave it in factored form. But they are equivalent. So either answer is good. All right, that is it for section 7.4 on adding and subtracting rational expressions, and then, of course, also handling these complex fractions, which is an extension of that. Have a great day.